6.4 is fitting power and polynomial curves to data. So there's a bit more involved in these fits than there were in the previous ones. So the basics are still the same. You put data into your tables, and then for a power function you use power reg, and for a polynomial you would use, well, you would use quad reg if it's a quadratic, or cubic reg if you're trying to fit with a cubic, and so forth. It does have those built-in capabilities, which is nice, but there is some important stuff to talk about with the power regression. So we'll do a lot of these in class, probably also, but the important thing to note for power reg is that you cannot fit the data if you have any values of x that are 0 or less than 0 in your data set. And that has to do with how your calculator is actually doing this fit. So if you consider the general form of a power function, which is that c times x to the p form, how it does it is it actually takes a logarithm of both sides of the equation and applies the log rules that we learned not so long ago, which expands it to log of y is equal to log c plus p times the log of x. Right? If you think about multiplication inside becomes addition outside, and the power gets pulled down from the x. Now what you have is effectively a linear equation in terms of log of x and log of y. But the problem is that you can't take a logarithm of a negative number. So if you have a negative x or even a negative y, it just doesn't work. So it converts the log x to its new x, and it converts the log y to its new y, and then it completes a linear fit in the same way that it did for linear regression to y equals c plus px, where p is now the slope, but it's actually the power of your power function. So it's messy, which means, and it only works in certain circumstances. It will give you an error if you give it data that is not positive. But there is another layer, right? Now we have so many different options to choose from that you have to be able to pick, what do I do? So determining which fit to actually use, if all of your data in and of itself is linear, right? It has that constant rate of change. We know we do a linear regression. What we calculated before when we found the percent rate of change, you can also see a linear relationship with x and the log of y for an exponential. That's where that one comes from also, is by applying your log rules, and then you get a linear function. If the log of x and the log of y give you a linear relationship, you have a power function. If it's none of those, it's probably something else. For example, like a polynomial fit that's more general. So we'll just do, I'm just going to give you some data example to go ahead and take and make an estimate with. So this is data for bird sightings per day. So say the first day you see 5, the second day you see 7, the third day you see 3, fourth day you see 12, the fifth day you see 17, and the sixth day you see 15. In order to determine what fit to use, you would just take the log of your x values and the log of your y values and create additional columns for those. So all the data that's entered in these columns came from just taking the logarithm of what's in these columns, okay? And just translating over. Log of 1 is 0, right? So log of x is 0. The log of 5 is 0.69897, so log of y is 0.69897. And you just fill in your table. And then you can plot the scatter plots of the data, x, y, x log y, and log x log y, to see which one of those is most linear. That's the one that you want to use to fit the data. So if x, y looks linear, it's linear. If x log y looks linear, it's exponential. If log x log y looks linear, it's a power function, just like I said earlier. So go ahead and play with all the data sets on your calculator and see, does it fit any of these? Maybe it doesn't, maybe it does. And you can also try your quad reg and your cubic reg with the same data set and see if any of those are fitting better, because potentially this could be a polynomial instead of exponential or power. Anyway, let let me know if you have questions, and we'll practice more in class.